Just a quick little video 367, this question 2 down here, okay? So it gives us the elevation of it. We can see a little 3D here as well. So it's a basketball and a bowling ball. The bowling ball is behind the basketball, okay? It gives us the diameter to do. So the first thing we're going to do is set up our elevation. The big circle is a diameter of 80, so that's a radius 40. So that's our big one there drawn it. And our smaller one then is a diameter of 40, which is a radius of 20. Okay, I'm just going to draw my center line here across, and my center line for my smaller circle. Okay, so in elevation, that smaller circle then is dotted, okay? Because it's behind the basketball. Okay. Now I'm going to bring down my circles from my plan, okay? So, if the basketball is in front of the bowling ball, that means the basketball is going to be here, and behind it then is going to be the bowling ball. So we're just setting the same radiuses again. They're all on the center line down here, so this is the radius for the basketball. And then the radius for our bowling ball. Point the compass there at the edge of the basketball. Swing your radius. And that's what we'll get. Okay? Now, our point of contact now in this one, right? So it's easy to find in plan, right? Where the two of them touch there along that center line, that's the point of contact in plan. Now, in elevation, it's slightly more different, it's slightly more difficult, slightly different than what we've done before. Okay? The two balls are in line with each other, right? I know the point of contact is going to be up there somewhere, roughly. Okay? What we normally do is join the centers in elevation and bring it down then in plan here when they're side by side, okay? But these balls aren't, these balls are behind each other. So, what we can do, okay? We can draw this exact sphere over here as a construction sphere out to the side, join our two centers, wherever our point of contact ends then, we bring it straight across here to this line that comes up and down the middle axis line, okay? So, it is a radius 40 to radius 20, so that's, so you add your two radiuses of your circles together. So it's going to give us 60 millimeters when you add our two radiuses. From the center then, I'm going to swing an arc that size. Come over here to the side, or you can actually just come straight across from this center because we've already the center found. So I'll come straight across from the center until they meet, which is there. I can draw back in that circle there now. Yeah. Next thing to do is join the two centers. So you're joining the center of the big basketball and the center of that construction sphere we've just drawn, the construction bowling ball. Join the two centers. Where it crosses the circle is here. That's like our construction point of contact that we found before. And you're bringing that across into the central axis line. Here. So that's our point of contact there now in our elevation. So that's how we get it. So just because we can easily draw the sphere out to the side of the circle as well and find points of contact that way and stuff as well, like we done with the cones and spheres earlier in the chapter. Yeah, so that's that question there, 367 question 2.